community kind of accepted me with open arms, despite the fact that I'm doing things a little differently from a genre perspective. It still fits under the country umbrella. So I've had a lot of success collaborating with other country artists and people outside of the genre, where I get to kind of use my voice in different ways and kind of be that musical Swiss Army knife.
That's awesome. Okay, so you're a musical Swiss Army knife, but we're also on we're on Twitch right now. There's a lot of gamers out there. Do you dabble? Do you dabble at all in gaming? And if so, what do you rock?
I dabble. Yeah, I have a Switch that I bring with me on the road. I want to shout out my little brother Caleb, who's watching this right now. He's a big gamer, and he's been putting me on to games that work for my lifestyle, which is that I need something that I can, keep portable. I need to be able to turn it off, keep it in my bag. So he got me on the Switch recently. I just beat Pokemon Legends of Arceus.
Hey, there you go.
And a bunch of Mario games just to kind of keep things light and fun. I know that people in here are all Raiders of the Lost Ark.
All right. Let's see what these are. I want to see the new Arcanas and stuff for Dota. Holy crap. Make sure that. Here, let me move my camera just for a hot second. I want to see. I just want to see all these. Right. Oh, yo, that jug set. Oh, that jug set looks so fucking sick, actually. I might actually play Dota. Holy shit. Actually, nah. I gotta go to bed early tonight, so I can't play tonight. But goddamn, they are doing a lot with this battle pass. Oh, yo. Okay, this is okay. That's okay. That Arcana style is okay. The Jug one looks really good. Like, they've been coming out with a lot of good stuff for Juggernaut. Oh, wait, what the hell? Wait, that's the Void Arcana? Jesus. It's a goddamn Cthulhu. Why does my sound suck today? Hold on. It's got text. Alright, never mind, not important. Dang. Okay, yo, Valve does such a good job at this shit. Oh, yo, okay, they have a custom fails for that. Okay, yeah, no, Void looks definitely terrifying, but, like, holy crap. How could you tell it was Faceless Void, actually? The normal model looks so different, but then again, it's like dark purple tentacles. Then again, I don't like this. Words. With the Warpath stacks. Okay. This is new animation for a multi. Okay. Interest. New update for the status of the Chan. This is the TA guy. Oh, okay. She has new custom traps. That's really good. And what is this, a Meepo? What's that mean? Okay, Meepo got the net update, whatever. All right, I mean that's all really cool actually. Again, the only one I'm really jazzed about is the Jug Arcane or whatever it is. Let's go to Hacker News actually. Let's see what's on the chopping block today. FAA, Stable Diffusion, Mac GPU. Not your grandmother's textbook. We clone a VM running VM in 2 seconds. Oh, yo, this is cool. Code Sandbox. We run your development project, turn to a link that you can share with anyone. Business can see not even running code. They can click fork and get exact. Oh, yo, okay, that's pretty cool. That's like being able to live copy a container. All right, that's except it's a VM. That's super interesting, actually. So let's see how they do that. Okay, we've been running sandboxes for a long time. Core premise is the same. Instead of showing static code, it should be running. You should be able to press fork and play whenever you wanted to. By running all code in your browser, alright. When you would look at a sandbox, you would execute the code. That was fast because we had full control over the code that was bundled. Okay, sure. This is not too dissimilar from having like a VNC. Why not? We were limited to the code that we could run in the browser. So if we want to run a big project that requires Docker, it wouldn't. So, okay, you're talking about being able to live edit code over a HTTP request. All right, interesting. I've got a sandbox. You would execute the code. Okay. I mean, in theory, the way you would set this up is that okay, you have multiple people writing to the exact same file, and then you sandbox the execution. I think that's basically what you would do. You could have, and that would just mean like you have multiple SSH sessions going on to the same disk, or two different sessions that modify the same underlying files, and then you could sandbox the execution. That's fine. So I'm kind of curious. Virtual machines are slow, expensive, bloated, and outdated. Yeah, because you're copying. You're basically creating a copy of the operating system in memory. So that will blow up your memory. That's generally why people tend to stay away from virtual machines over like things like Docker and the system when you design your systems. VM power most of the cloud. Okay. Most experiencing developments in the field create Firecracker to power AWS Lambda. I have no idea what Firecracker is though. It's used by companies like Flycode and Scode. It's written in Rust. Okay, I'll check out the repo later. It spawns a micro VM. Okay, instead of waiting 5 seconds for a normal VM to boot, you get a micro. Okay. So how does this micro VM actually work? Is it just like a bare bones state of the system that gets inflated? I actually don't know what this means. Like, what's the drawback to? That's like the first thing when I look at this. I'm like, what exactly does the micro VM give you? I mean, other than speed, and what's it taking away for that speed? That's kind of the question. Okay, even though you can start dependency, you need to clone your repo, install dependencies, and run dev server. Yeah, correct. And this is actually one of the problems with virtual machines and not sandboxed or not containerized instances. The reason why is because you have to manually install dependencies, but then if you don't clean up after yourself, then the next person running it will have conflicts. So for instance, let's say I have repository A and repository B. Repository A relies on one version of Python, repository B relies on another one. So let's say repository A is some legacy code that runs on Python 2.7. Repository B runs on Python 3.6 or whatever they're at. So if I run repository A, and then I specify that repository to install Python 2.7, and then I want to reuse that instance for repository B, I'm going to get a version conflict and my code is going to fail. And so being able to clean up after you're done using the machine is actually a real problem. And it causes a lot of headaches where tests will randomly fail just because you have different code bases and expectations running on the exact same machine, one after the other. Now, an obvious way to solve this is to tag machines, right? So, okay, you have a machine dedicated to repository A, and you have a machine dedicated to repository B. That way, if we ever compile on repository A, we send it to cluster 1, and then we compile repository B or do operations, we run on cluster 2. But that seems extremely wasteful. Like, you are limited by the fact that you can't clean up after yourself in order to run all these expensive machines, and the fact that these machines have to be running, ready, and available costs money. So a lot of times these machines are straight up doing nothing. So in other words, because you can't clean up after yourself, you are forcing yourself to take on more machines, which is very, very inefficient and very, very stupid. So, all right. Anyway, enough of that rant. Let's actually look at more what the hell they're talking about. If you wait for a machine to every time you click on fork, it would be a disaster. Yes. Because you would have to boot up the image or machine and then just run whatever the hell is going on. Memory snapshotting. Okay, fine. This is probably just saving the state of the memory. Alright, does it spawn? Only spawn VMs and resumes VMs. Yeah, okay. Virtual machine, control over the environment, we control very virtual CPU cores they are. Yeah, sure. This is everything that you would expect out of a virtual machine. You can pause the VM inside. That only pauses your code. It pauses the full machine, full stop down to the kernel. Okay, so you have a virtual copy of the entire operating system that you're going to save to a state and then be able to reload. I think that's pretty much what they're saying here. Okay. So, in other words, when you take like an operating system and a virtual machine, you copy everything. So that's like the state of the CPU, the state of the memory, the state of the disk, etc., etc., and then you just serialize it. That's really what this is. 3 MB this file week 4 GB. Okay, sure, why not? Starts from a micro VM. Again, I don't know what this micro VM is. I'm guessing it's an on-demand, so it doesn't actually inflate the entire 4 GB memory. It inflates what it needs to, and then does things on demand. So that's the way I'm gonna guess this, because I've seen this problem before. So instead of inflating the full 4 GB, which can take like a second because you're reading 4 GB off a disk, you're gonna be inflating, maybe a chunk of that, maybe like 100 megabytes or something. Load that into memory and get just enough resources just to start your machine. I think that's what the micro VM is, and then it'll load the rest on demand. That's probably what happens. So in other words, you probably pay you don't pay in terms of startup cost. You probably pay it over the runtime of the machine. That's probably what I would guess. Many cloud instances will hibernate your VM after 30 minutes of inactivity. This means they'll stop your VM to save housing costs. Yes. When you come back, you'll have to wait for your development service to initialize again because of full VM boot. Yes. Firecracker will hibernate your machines. Save memory to disk. When you come back, VM is restored. Yeah, this is a consequence. This is just a consequence of the micro VMs. Fine. Because you can afford to load things on demand. This is basically just a derivative of lazy loading, actually. There's nothing new under the sun. It's like for a web page, right? I can load all the text, and then I can load all the images later, instead of trying to load everything all at once. And it's the exact same thing applied to virtual machines. I think that's basically what they're saying here. So why the hell not? Sure. No caching, pre-installed node, pre-installed build cache, whatever. New development, we don't have to remember to roll back migrations or install dependencies with specific branches because of a fresh environment for every branch. Yeah, because it's technically the exact same machine. You just have multiple sessions going to the exact same machine that everyone's using that has already been set up. Okay. We use this host to internal tooling cheaply. When a webhook comes in, blah, blah, blah. After 5 minutes, hibernates again. Okay, so you still get the hibernation effect. Okay, fine. Save memory snapshot and resume. Okay, so it's a stateful snapshot, and then you can roll back whenever you need. Sure, why not? And then with that you also get versioning, actually. That's pretty goddamn cool. New background. Not really. I don't know what you mean. Okay, you can play it here. It retains states between hibernations. However, the challenge lies in speed. Memory snapshots are yeah. So let me take a guess here. Because how big these memory snapshots are, they're just gonna take the delta between each. So if you're looking at sandbox and press fork, we would pause the VM, save the snapshot. Yes, this is the traditional sandbox. Wait 10 seconds. Okay, so let's see how they do it. It takes about 1 second per gigabyte. Why? How do you manage to do this? In many cases, you're restricted by I/O. Yes. Resident right. Correct. That's fine. Throw in. We need to find a way where we don't find it so many bytes to disk. We tried incremental snapshotting. Okay, that's what I was asking. I was pretty sure they did incremental. Sparse snapshotting. Okay, reduce the amount of time between snapshots. In the end, we found a solution. Tenfold, but explain that we understand how Firecracker saves a snapshot. Alright, when Firecracker loads a memory snapshot for a VM, it does not read the whole file. Yeah, that's what I suspect. I literally called this. They don't load the full memory snapshot. They have to take a piece of it, but then what? Okay, so they take a mmap a system call to create a mapping of a given file to memory. File's not loaded directly into memory. There's a reservation in memory saying this is part of the memory that corresponds to this file and disk. What? L page fault. Okay, kernel will read the memory. Okay, yeah. I see. So it's the same way you would use page memory, except you load a chunk of it into memory. All right, sure. That mmap will load parts of the file into memory that are actually being read. Oh, okay. So this is literally just taking the whole, you have physical memory and you have virtual memory, right? It's just taking advantage of the exact same mechanism here, and it's just using the exact same thing. It's a native underlying Linux implementation, for any operating system really. So that makes sense. So what happens if you write to memory? Does it get synced back by no? Default no. Okay, they're just talking about like physical and virtual pages for memory. It's fine. Fast flag. Map shared. You will actually be able to do this. This person can move off IO. Dang. Really fucking good. Okay. Copy on write. I think this is a really good system design question, actually. How would you do basically OS emulation or live sharing of it? I'm going to link this in the chat, but basically, and for the rest of you guys to read. But I think this is a really good primer on like system. If you're looking to do a system design, you could probably, this is probably a good example of the thinking. So with that happy note, let me actually bring on my client and see what's up. Let me log into my Zoom account. God damn it, sign me out. Hold up guys. Something kind of messed up on my end. Let me join Zoom meeting. Let me message him. Let me see what's up. Okay, cool. Hey, hello?
Hello?
Hey, what's up?
Hey, man. How's it going?
Doing good. Yeah. Catch me up on everything that, how was, after Tuesday's session, did you get practice in? Do you have, any updates for me?
I actually, reviewed some chapters on, cracking the system design interview. I read the chapter on, replication and sharding, and also the one on consistent hashing. And I also went over the tiny URL problem by myself, and I did it in Excalibur by myself. Okay. And then for this recording, I did design placement for the replay analysis.
Cool. Question: do you have like the practice diary going?
Do I have what?
Do you have a practice diary for your system design?
The notes I sent you, I was going to copy them to my Google Doc eventually.
Okay.
So yeah, that's an idea. I did write some more entries there, like a separate section for system design.
Okay. Yeah, I would recommend you have like a separate tab for system design, and you could put it in Google Docs or you could put it in Google Sheet, whatever.
Okay.
But I'd probably recommend, in some way, you want to have a link to the Excalibur.
Okay. Awesome. Okay. Do those expire? You ever experience that? Because I couldn't find it online if they expire or not.
If they don't, just to be safe, you could always like upload it to Dropbox, your personal Dropbox or whatever. Because JPEGs, like just save it as a JPEG and upload it. That way you understand. Okay. Just in case they do, but in my experience they don't. So.
Okay. Cool.
So
sounds good.
Take a look at your notes here. Give me a sec. I would say the notes are looking a little bit light, but let me take a look here.
Mm-hmm.
Let me copy paste them. Give me a second. WordPad. Where's WordPad? Here we go. Okay, so with the diagram relation, I made the mistake of sometimes saying SQL. Okay, yeah, just say relational database in general, because there's many versions of MySQL, but whatever.
Mm-hmm.
Only cache metadata database. The heck? What does that mean?
Let me see. Let me pull up the notes.
Only cache metadata database. I don't understand.
In my diagram, it looks like I only put the caching in front of the relational. So if you look at the diagram,
right,
there's really no caching between the object store and the cache. So the way that Grokking does this is they put it in front of both. That's what I meant there.
Okay, I see. Then that just that's so right now you're doing the delta between your answer and okay.
Correct.
So the question now you need to ask is why? Why did I miss that? Is it necessary? Did they do something? What was the question? So didn't ask limits on data URL failing due to hash collision. Yes. Didn't ask how many records to store, 1 year, 2 years. Yeah, data persist. Basically, the question here is data persistence. Do I want?
Okay.
That's going to be part of your framework.
Okay. Data persistent. Okay.
Didn't ask self how to handle cache properly between metadata and object store. Okay, yeah. How does the caching mechanism really work? So it didn't ask limits on data URL. Making a URL, yeah. So hash collision is going to be a problem. I wouldn't say limits on data or URLs. You should ask yourself in what ways can this go wrong.
Okay.
I think that needs to be part of your toolkit. Whenever you look at like system design problems, they're sufficiently complex, right? Like there's many different ways that we can take this, and because of that, there's many different ways that we can fuck up, right? And there's many different ways that each component of the system can fuck up. So this is like how you're going to need to ask yourself. So in other words, if I'm generating URLs, what ways can I generate URLs that what are its own problems? You know, what's its drawbacks? What is the way I can fuck up? And one of the ways to fuck up is what if, because effectively these are hashes, right? What if there's a hash collision? It's no different than like hash collisions on hash maps. So, so then now I was like, okay, so then the question then becomes, all right, given these questions, could you still arrive at the, would you now be able to arrive at the exact same, what's it called, answer that Grokking did? That's the next question to ask.
Yeah, so the caching would be more, it'd be better explained, and also the collision explanation would be better explained as well.
No, we're not talking about the explanation for it. We're talking about can you produce the similar or exact same answer that they did if you ask those questions at what point? So for instance, let's say I have your diagram, right? And I ask myself A, B, C, D, E, F, G, right? And then we come to like H, I, J here, right? Where does H, I, J need to go in my sequence of A, B, C, D, E, F, G? And if I do that, will I get the exact same answer that Grokking did? That's what you need to do. Does that make sense?
Yeah, that makes sense.
So that's what I'm asking you here. So it's not enough that you have a delta. It's enough now that you have these. Oh, I need to ask myself this, and you have the delta. You need to now run through the whole problem again using your new updated framework. Would you get closer to Grokking? Because it's one thing to say, oh, I learned this, whatever, move on. Because and honestly, if you do that, that's fucking bullshit. Because everyone says, oh, there's lessons learned, whatever, move on. And those people never learn a damn thing. Like I'm sure you've met people like that who say, oh, I learned so much because I lost $100 million on my business. I'm not going to lose $100 million on my business ever again. And they fucking end up doing that because they never think back, okay, would this really have worked? Yeah, so it's what I call fucking bullshit. Because you have this idea in your head, but you never know if it works until you test it out. So didn't write down cleanup service. Okay, again, you have the delta here. So then if you need a cleanup service, the question then becomes, what is the chain of questions that you would need to ask yourself in order to get to the cleanup service? So I'm going to pose that to you. Let's walk through that exercise. You had an approach. What questions would you have to ask yourself in order to get to the cleanup service?
Okay, so going back to the non-functional requirements, I state the storage, right?
Okay.
Yeah, like up there, the 500 gigabytes of storage. Eventually, the links are going to expire sometime, right? That's another thing I did not talk about. I'm trying to read the notes here, like the time to live.
Okay. I would argue there's probably another way to slice and dice this.
Okay.
So it's like, okay, that's a non-functional requirement. Someone says, hey, yeah, these links need to expire. That's one way. But that's also a dumb way because that means that you're begging someone. The implication is that someone needs to tell you that.
Right.
Which means that you would never be able to figure it out on your own. You see, like, how that line of questioning doesn't really work? But I would argue you could figure it out on your own if you ask yourself the right question. My question to you is, what is that question?
Okay. Let's see. So if I run through the system, so let me see. I'm looking at the diagram now.
Not the diagram. I'll give you a hint. It's in the logic of the system. If I took the system to its logical conclusion, there would be, or like kept pushing it, the answer would, the next question would be very obvious.
Oh, okay. Yeah. So if you run this through a user interaction, you can say, okay, this is the path I'm going to take to delete a record, right? So then you run through the system here that you designed, and you can come to the argument, okay, do you want to really hit the, do you really want to hit the database with deletions, or can they wait? Do they have to be real time, or can the user wait for that to happen? And that's when I can introduce the cleanup service and talk about it, that it can run at low peak times and when you expect the least traffic. And the cleanup service will go into your database, mark that post as deleted. It can go to your object store, delete that, also from the cache, and also from the key generation service. It should take back that unique URL and send it to available URLs.
Better. It's better. I mean, to be fair, you do have, like, in your functional requirements, you said users should be able to delete the text file uploaded, and by, at least in pastebin, right? So yeah, sure. You can also be able to delete a link to the pastebin or the file itself. And yeah, that's one way to do it. Another way would be, hey, if I keep producing have people upload files after file after file, and I never purge it, I will be scaling my fucking disk. And is that something we want to entertain? Because if I think, the question I would ask myself in general is, how can I be more efficient? That's fundamentally what we're doing in system design, right? We design a system, and in theory, if we had an infinite amount of money, we would just throw an infinite amount of resources at the problem and call it a day, right? But and if we had, if we were like fucking, a god tier Elon Musk engineer or whatever, well, we're not that. We're trying to be as efficient as possible. So the question of efficiency comes in. It's like, hey, yeah, if I just hold my pastebins forever, I'm gonna have to scale out my disks forever. So can I avoid that? That's the first question. Can I avoid having to do that because it's way too fucking hard and way too fucking expensive to do that? So instead, can I just be a little bit smarter, a little bit more efficient about the data I hold? In which case, that would lead me to the question of yes or no, and then if it's yes, then I can come up with the cleanup service.
Okay, that makes sense.
You see how I just logically took the system to its conclusion to say, hey, yeah, this is either very fucking expensive or very fucking hard to deal with. I would rather try to avoid the issue altogether. It's a very powerful heuristic, and I would recommend you write that down. Put that part of your
Yep. Okay, I got it here.
You see how there, like, I didn't have to ask the interviewer to save me. I could figure it out on my own. That's what I mean. Your framework should be able to guide 80-90% of the decisions. Like, it doesn't matter what the interviewer is going to do or say. I have an answer for it. But I should be able to anticipate it. And, with that line of questioning, right? How can I be more efficient? What is the logical conclusion of the system? I was able to come up with the cleanup service. That's what I mean. So you need to be able to do that. Like, what other questions in general do I need to ask myself? Not questions specific to the problem, questions in general. And the how can I be more efficient is a wonderful, wonderful tool. So load balancers in front of database. Now that I gave you that, I want you to try and do the exact same thing with the load balancer. So where in your thinking would you have to come up with the load balancer? Let's ask that.
Okay, let me see.
Oh.
Okay, so.
Okay.
Yeah. Hello.
Yeah. Hello.
Yeah. This is not talking about the one in front of the application server, right?
This isn't. Well, wherever you said there's a delta, right? Load balancers in front of the database.
Oh, okay. Yeah. So, so between the application and the database, there's a cache there, right?
Okay.
Every time there's always going to be latency, right? Going from your database to the object storage. So why not bring in that data inside to the cache? Do the LRU eviction policy. We only care about
you wrote load balancer. So we're talking about load balancer right now, not caching. So load balancer in front of the metadata plus object store. That's apparently what you wrote.
Okay.
So my question now is, what line of questioning do you need in order to figure out, hey, yeah, I need to have a load balancer in front of this?
Okay, yeah, you don't. Your databases are going to have multiple nodes, right? So why don't you introduce a mechanism that it's gonna distribute all that load evenly? You don't want to just send it to all one node, right? One database. Okay. So when you introduce the load balancer, what that does is it can tell if a node is down or if it's responding too slow. It will stop sending requests to that. So doing that in front of the databases, it can ease the load on your databases, and you can add more records as well, more nodes to scale that.
I think you can be a little bit more succinct with that. I want you to take like 5 seconds to really think about what you want to say, or take some time to think about what you want to say, and sell me the idea in like 15 to 20 seconds. Make it plainly obvious. Make the way I want you to convince me, like you're a used car salesman trying to sell me some shitty fucking Honda Civic, right? You didn't make the words and what you're saying punch me in the middle of the between the eyes, right? Make it obvious. So make your explanation a little bit cleaner. Take your time.
Mm-hmm. Okay, so you can run into the situation when you're going from your application server to your databases.
Okay. What? You want to try again? You want to take some time to try again?
Yeah. Okay. Okay. Based on our non-functional requirements, the system has to be very reliable and highly scalable. So why are we going to just send all our requests to the database without the load balancer? What the load balancer does, it can distribute load. So there's not a lot of strain on your database.
You are recycling the definition of load balancer. That's the thing.
Oh, okay.
So I'm saying like, okay, let me do this one for you, and maybe you'll understand. So okay. I'm going to apply the heuristic of let me take the system to its logical conclusion. We are going by nature of uploading files to the paste bin, we're going to be growing our object data storage. This is the main point at which our data will grow. Not the text we generate. Text we generate is like super fucking small, like 500 bytes or 50 bytes or whatever, how long the URL is, right? Or the hash. But the files themselves are going to be like kilobytes, like megabytes. So this will grow very fucking fast. So we are going to have a strain on the object storage. Now, how can we mitigate the object storage strain? We can have two ways, caching and have file pointers, but then that's pretty goddamn hard. So, but if we make if we do like some server replication or database replication and then put a load balancer in front of it, that will alleviate our problems. Did I just sell you on the solution right there, or were you not convinced?
Yeah, because what I saw what you did is you like introduced the story, right?
Yes.
Or use case that the user's gonna see. Like by saying by nature of the database, we will be growing our database, right?
Mm-hmm.
So yeah, that convinced me.
Yeah, exactly. Almost 90% of the time, when you want to convince someone, you're gonna tell a fucking story, and the story here is literally the problem that the user is fucking doing, or the system that they're using, right? So, if you can derive it from the story or the interactions that a user is doing or will do, it's almost always the best convincing point.
Awesome.
So, and of course, this is like one of many ways to do it. I'm giving you the most obvious, simple one because, later on down the line, you might have to start considering, hey, well, what about the maintenance of this? What about the developers I need to hire in order to work on this? Maybe I need to consider them in the story as well. But for now, almost always the end user is pretty much what you need to do. But I'm getting ahead of myself.
Okay.
So, God damn, I'm trying to pull up the Pastebin login. All right, but yeah, I really want you to make sure that you write all this down because I really don't want to repeat myself more than once. If I have to say this again in a future session, we're gonna have a problem. Okay, I only like saying things once or twice, but then after that we're gonna have a problem. Okay.
Okay.
Cool.
Yep.
All right. Next thing. So let's actually look at your replay. Let me see how you actually approach this problem. Oh, actually, wait. You have keygen should point back to AP app server, not database server, since app server should handle logic of keys. Actually, why don't you do this one? I've given you 2 examples. Do this one on your own. See what happens.
Pulling up the file here. keygen should point back to app server, not keys. Okay. Okay, yeah, so yeah, the delta I saw there, as I explained there, the key generation server was pointing to the relational DB.
Okay.
So, so I'm trying to convince the delta on why we need to point it to the app server, right?
Why do we even need to have this? Yeah. Why do we need this keygen to point back to app server, not database?
Right, so that's because you don't really want to put application logic in the relational. So you don't want to put application logic in the database portion of your design, right? That should be handled by the application server. So running through this use case, the user hits application server. They go ahead and they want to post a key, right? It goes through the cache, then to the database. The key generation server should be returning back, not necessarily to the DB, but somewhere in the application to the user, or not to the user, but that can then get sent back to the database.
I'll take a pause there. Remember, 15 seconds to sell me. I want you to make sure that whatever you say sells me in 15 seconds. So. And also, just another thing is that you're arguing for a design, but I want you to really argue on point of a derivation. There's a subtle difference. I'm going to point out, each time I gave an answer, right, I just grew it from the use case and said the trade-offs, right? You were much more convinced than if you threw a solution in front of me and then just like came up with reasons. I want you to take the other way around. Does that make sense?
Mm-hmm.
Okay. Yeah, take your time with it. It's not an easy exercise, but the more you do it, the better you'll get.
Mm-hmm. So just thinking out loud here. Okay, so the argument is to say why the key generation server should point to the application server, right?
Well, I mean, technically the service is in the application service. That's the thing. So.
Okay. Okay, so by the argument, I want to talk about the use case where the user is gonna post a new node, right? Is that going in the right direction?
You're asking why does the user need a new node?
No. I'm just going through the flow to explain where we would ask for that key.
Okay.
So just gonna quickly talk about the use case. The user is gonna ping the application server and he wants to paste a note into the system, right? So the system, prior to saving this note, we have to generate a key. because based on the requirement, it says the user is going to get a unique URL.
Sure.
So prior to sending that request, or prior to sending all that request past the application server, you need some sort of payload to send to your databases, and that's going to include the file data, file size, etc., and the unique key you got from the key service. So by that argument, I would point the key generation service to the application server.
I think you could say that a lot more succinctly because I had a little bit of trouble. Remember, 15 seconds to sell me, otherwise I walk out the door. You know, that like used car salesman. I mean, to be fair, I hope you're not selling some shitty cars, but you get the idea.
Okay. Okay, so say you're a user, you want to post a note to this system. You don't want to take say you're a user using the pastebin service. You don't want to take a full route to generate a key generation server. You're talking about hopping between caches, hopping between two databases and object storage to grab a unique key.
Okay.
Why don't we reduce those trips and latency by just asking for that information from a key generation service?
Better. You're starting to get there, but it's a little bit murky. Let me take a stab at this, and then maybe it makes sense to you. So your current configuration implies that we can grab the key and the object store ahead of time in one database. The problem is that this introduces complexity because you're going to populate things from a key relational database into an aggregate database. And I'm going to say it's too fucking hard. Why not separate responsibilities?
Okay.
Did I sell you on that?
Yep, that makes sense.
Yeah, and it just boiled down to single responsibility principle, which is a pretty familiar concept to anyone. So all I did here was instead say, hey, yeah, let's not have an aggregate database of everything because it's a pain in the ass. Literally, that's the whole argument. It's too hard.
Yeah. yeah.
So I think the this is where like, oh yeah, the too hard heuristic actually really pays off. So.
Okay.
Yeah. I mean, there's also like the something to be said about like load balancers, and I'm gonna give this one to you as well, just as a side commentary. When you use a load balancer, what people really kind of forget is that load balancer just says, hey, I'm gonna go to. It's just a redirection, right? It just says go to A B C D E server. What people usually fuck up is that they try to make the load balancer keep track of application server states. That's incredibly hard. Because, again, load balancer is just a pointer. It's one responsibility only. So when people do things like, oh, in application server A should have state X on it, right? Application server B should have state Y on it. And if we need to deliver to X, go to X. And if you need to go to Y, go to Y. It gets fucking hard, right? Because what happens if the status of the application server changes? So, for instance, I don't know if you saw, like, the first 20 minutes of the stream where I went over that virtual machine thing.
Which VM, sorry?
So I was looking at a blog post actually, where there is a company that shows how they can have people share the same instance of a machine and work on things collaboratively within that virtual machine. Okay, so what if that application server was a machine? So it's like, oh, it's in state A, and therefore go to state A, and then well maybe we need to replicate that instance just in case it goes down. So then now it'll be in state B. So then redirect the people from state A to state B, etc., etc. You kind of see how that gets too hard, right?
Yeah. Oh yeah.
So I mean I've made that mistake before, and it's a big pain in the ass. So having the too hard heuristic, like the holy shit, this is way too fucking complicated, should ring alarms. So that's what I mean by adding questions to your approach. Is this too fucking difficult to do?
Yeah, man, regarding the load balancer, in Grokking it says, okay, you can put a load balancer for none of these app servers. If the machine is not responding, the load balancer will stop sending requests to that, or if it's too slow. So I think that shit fucked me up there too. 'Cause I read it there and in the past too. So It's good to know that it's just a redirection.
Yes, it's just a redirection. That's it. Because in theory, the most efficient way of doing it is like literally you have application servers that do exactly the same things. Like think of it like an Amazon fulfillment warehouse, right? And your servers are like Amazon employee, Amazon warehouse employee A, B, C, D, E, F, G. They all do exactly the same thing. So in case one person goes on break, you can give it to B, C, D, E, F, G. So the load balancer just redirects the flow. But if every single worker does exactly the same thing, you don't have to keep track of those individual workers and redirect it to someone who is more specialized in, say, delivering packages versus someone who is, better at operating the forklift or whatever. You don't have to keep track of that. It's the exact same thing here. I'm just putting a human face to it.
Okay.
So
how would you introduce the load balancer in an interview then?
Mm-hmm. I would say, let me go through the system. The inefficiency at some certain point, now that I've tackled these other obvious inefficiencies, is that we have high traffic to a particular component. Now, I would ask myself, is this particular component homogeneous or not? And if it is homogeneous, then I can have replicate, then I would be able to assume A, I can replicate it. And B, if I can replicate it and it's stateless, then I can put a load balancer in front of it. That's usually my trick. But of course, you'll develop your own as you do more and more systems. And you keep asking yourself these questions over and over again, but this is that's my rule of thumb.
Awesome.
So, in other words, let's apply that to the database, right? Object storage, right? In other words, I'm implying that the metadata here, every single metadata instance of these are all just tables, right? Each of these storages are just going to be A, B, C, D, F, G, and A, B, C, D, F, G are going to be eventually the exact same, are eventually going to be consistent. So, object storage, I'm going to have A, B, C, D, F, G replications of the files, and these are all going to be consistent eventually. That's the implication.
Sure. Cool.
Yeah, I can also, in theory, have a master slave configuration on the object store and metadata storage if I find that I need to be able to, if I'm going to face very high traffic on there, or I could just have master list where it's all consensus protocol and whatever. That's getting a little bit more into the weeds. But eventually, I am already acknowledging that at some point, if I am dedicating myself to a load balancer, that all these are going to be stateless. So that's kind of the direction I'm thinking of. But you see how, if I put the load balancer in front of that forces me into a particular decision.
Correct. Yep.
So it's a little bit complex and a little bit abstract. But if we go to DDIA, it'll clear things up a little bit. Right now, I'm just kind of giving you the framework in which you need to operate in. So. Okay, with that, let's actually look at your replay analysis. I actually have no problem with what you did up here. I think it's perfectly reasonable as an approach. I think that you should also, we'll do the delta later, but let's actually load up your replay and let's see what's up. So okay, so let's see how you do it.
Let's design a big spin web service where users can store plain text. Users of the service will enter a piece of text and get randomly. Okay, let's start with our functional requirements.
Okay, fine.
User should be able to upload a text file and get back a unique random URL.
Okay.
User should be able to. You're not sharing your screen?
Oh yeah. Sorry. Let me share your screen. Sorry.
Okay. Cool. Awesome.
Let me do that. Share screen. I'm gonna share the. Okay. Can you see that?
Yep, I can see it.
Okay. Fine.
Text file uploaded. User should be able to share with other people.
Okay. So users be able to share with other people. You should be a little bit more specific on that one. Small little tidbit. Share the text file or share the link. Technically the link, yeah. So you would be a little bit more atomic about that.
The requirements. Okay.
Small thing.
We want a system that's dependable.
Sure. What does that mean?
Service, so that means it's going to be on the web, obviously. So the first thing is to say we want it to be highly scalable and highly available.
Okay.
And the reason for this is we want to be able to have a bunch of users join our service and have a good experience. So if we only have one machine, one web server, and it's flooded with thousands, millions of requests, our server's going to go down, and this is going to be a bad experience for users.
Okay, you heard what you said there, right? It's a little bit. I would say that's a little bit too generic. Of course, like any server, it's going to be like, oh, if we go down, what is like is going to be bad for users. Of course, it's going to be bad. The question is, how much are you willing to tolerate?
Okay.
That's the real question. Like, how much of that? Because you're going to make trade-offs eventually. So the question is, how much? What do we want to have that is absolutely not negotiable, and what do we want to have that we can kind of like, and trade off on. Like, remember on Tuesday, I said, hey, maybe we don't give a shit if the difference of likes is between 1 million and 1,000,001. That's one trade-off we're willing to make. But for like low counts of like 1 or 2, we kind of want to be a little bit more accurate. So stuff like that. What are you willing to give up? What are you not willing to budge on? So it's prioritization. So scalable is kind of already implicit in that. So available is fine. Scalable is it's implicit. That's what these systems are supposed to be.
So let's say there's a 100 to 1 read write ratio.
Okay, you're just doing back the envelope calculation, sure.
So
okay. So 500 gigabyte storage. What does that tell you? Let me ask that. If you're seeing that, what are you thinking right now?
It's a lot of storage. You should definitely consider a TTL here.
Okay, so 500 gigabytes, right? I can walk down to Best Buy right now and buy a 2 terabyte hard drive, no problem.
Mm-hmm.
So, in other words, every 4 months, I would just need to buy a new hard disk.
Mm-hmm.
That doesn't sound like a lot. That's the thing. When I'm looking at this and I see 500 gigabytes of storage, that's 500 gigabytes of records per month, right? That's probably not, in the first 2 years of the system, probably not a whole lot. But after the 2 years, I'm going to need to think about, like, oh, yeah, because I'm buying, like, hard disks every single fucking 4 months. It's kind of a pain in the ass to keep uploading, replicating, and et cetera, et cetera.
So here, should I say what happens in 10 years, 5 years, right? And then come up with the number? Is that a good approach there?
No, my point here is to look for something that may seem weird, out of the ordinary, or things that you don't want to handle. So the point of my question was really so that way you train your instinct of like, hey, this doesn't seem that bad, or oh, this seems bad. It's a smell test essentially.
Okay.
Does that make sense?
Yep.
So in other words, I'm going to initially think when I see this, it's not that bad because I'm just going to go to fucking Best Buy every 4 months. So the estimations here kind of imply that. So let's see. Keep going.
Right. Do some conventional analysis. There's one. Okay, so it's 500 million per month.
Okay, I understand what you're trying to do here. So, in other words, now that you're doing that, using 100 records per month, you broke down the velocity, right? So, but the 20,000 records reads per second. Okay, we can't get away with just buying more fucking hard drives from Best Buy. We actually have to handle the flow of information, right? In other words, your bandwidth is now your first choke point before your disk.
Okay.
So in other words, if I'm prioritizing what the issues are when it comes to the system, I'm gonna immediately prioritize. Hey, this is the most obvious thing that's going to be killing my system. More users means higher throughput, higher bandwidth, and we need to deal with this. Yeah, this is where I would first immediately turn to my system design, just based on this alone. Okay, cap theorem, I have no problem with. Because consistency, yeah, you have availability and partitioning, fine. So you need to be able to specify your tolerance. I would also actually that's fine, because they do memory estimates inside of the paste bin. So that's a point you missed, but I don't think it's that important a lot of the times unless you're dealing with something that's highly computation. But
okay.
And effectively, you're pretty much coming up with hashes, so hashes are very quick, so it's not really that bad. Maybe eventually,
okay.
But go ahead.
Yeah, so for the memory estimates I see in the graphing, they go from that, and then later they say, oh, we can just load all this into a single machine and just cache everything there. Not everything, but have like a cache of 256 gigabytes.
Mm-hmm.
And they get that number from these calculations here.
Mm-hmm. Yeah. But I think the way I see these numbers is really the pain points, right? Because hashing doesn't take very much unless you start putting throughput, right? So if I start throwing more users at the system, my throughput is going to be affected, right? Which means the first part of that is going to be the I/O of the disk and databases, which means I'm going to have to start parallelizing that stuff. But let's say in a perfect scenario, I handle that, right? The next thing will be generating enough hashes, right? And generating enough hashes will mean, hey, yeah, I might need to start caching some keys. That's being able to do that. Have a sense of what is important and what is not. What is higher priority versus something that's lower priority. And in this case, memory estimation is probably low priority.
Okay.
Because hashing is a very, very fast operation. But if I handle this, then I know that's going to be like the next thing I need to handle. Does that make sense?
Mm-hmm.
Okay, so let's see what you do here. So you come up with an overall user application database. Sure, user.
It should not be guessable.
Okay.
Does not say anything about them providing their own unique URL, so we can skip that. So if the user does not have the capability to define his or her URL, we should be able to provide them back some sort of URL, right? So
sure.
Let's say we have, we can use the alphabet, 26 characters times 2. This accounts for the upper and lower case letters. Let's say we also want to.
Okay, you're doing estimations of that. Fine, sure.
Storage.
Keep in mind you're not gonna have these in the interview. You're not gonna have like access to a calculator.
Okay.
So I'd recommend you come up with a good heuristic here. In fact, if it's 26 characters, I'd say 25 times 2 times 100 is a good estimate, actually. Yeah, so that's what I would do. Like I would use 25 instead of 26 because then they would just round up to 50.
Okay.
Back of the envelope being off by 10-15% is like margin of error. It's whatever.
Okay. Mm-hmm. Okay. So let's say that storage is cheap.
Okay, so yeah, so your post. So now you're defining your schema. So the first thing is that when you're breaking this down, you see this. You want to first define your models. Okay, that's fine. I have no problem with that. So you're defining models. Okay, let's see what you do here.
And get it returned back to them.
Sure. Okay, so you're coming with a very simple design right now. Fine. Okay, so then
With the unique URL, so you can share this. User should want to delete the text off the upload. So we go to the application server. The application then sends the user to a user management to a document management page that has all the postings updated by this user. And there you can delete it, you can edit it, share it with them. The post is going to have all the content, right? Do we really care about relational? Are we going to do joins between different posts? Probably not.
okay, that's fine. Yeah, you don't need to do joins. Sure.
Makes sense. So this essentially is just going to be a blob of text data.
I see. Okay. So let's say I'm in this position. Oh, actually, wait. Hold on. Let me look a little bit more. Let me see what you're doing here.
The relational data should have the post information. Sorry, the database should have the post information, right? What if records per month? What if we offset this into some sort of NoSQL storage? We don't care about relationships, so let's say storage here it is.
Okay. I see. So your reasoning for starting to insert the object storage is just because you didn't care about the joins.
Mm-hmm. Correct.
I think that's the wrong way to think about it.
Okay.
Do you know why?
Is it because I didn't mention there was unstructured?
No, it's actually a lot simpler. It's nothing to do with technicals, by the way. I'll give you that hint.
You want to make it more simple, the system. You don't want to put everything into the database, right?
Why?
The argument for that was
Your argument for creating an object store is that you don't care about joins. I'm saying that's a bad way to think about it, or a bad reason for it. I'm not saying your answer is wrong. What I'm saying is that the reasoning that you take is wrong.
Okay.
And I'm just asking you why am I saying this?
So I said, okay, let's move the blob into object storage because I don't care about joins.
I'll give you a hint. We've mentioned this probably at least twice already.
Okay, this I guess a better argument would be, okay, how can I be more efficient? You don't want to keep a bunch of data into just one database, right?
Maybe not. I would say keeping things in one database is actually the fastest because, and you just replicate that one. That's pretty fast to me because if you have two databases, you have to coordinate between two databases. Query one database, then query another database that is entirely separate. I mean, it's not necessarily bad, but I think there's a lot simpler, easier way to think about it. I'll give you another 30 seconds before I tell you. Okay. You want to give a shot?
Okay. With 20,000 records per second, do you really want to throw all that bandwidth to just one database, or do you want to offset the bigger? Do you really want to send all your file information to one database, or do you want to offset, for example, the blob of the file to another database point?
Better. I mean, you definitely have. It's better. Don't get me wrong, but I think it's a little bit more complicated than it needs to be. Let me make it very simple.
Okay.
The user is going to want to upload a text file. That text file could be anywhere from a few words to a few megabytes. Now, you write here post content user, right? Assuming you have a very naive implementation, the content I assume that you would stuff everything into the content. In other words, one of your columns will have an entry that's a couple megabytes long. That does not sound terribly efficient to me.
Okay.
So, in other words, if just going by what the end user expects, that's it. So, you see how that chain of reasoning is actually pretty simple?
Mm-hmm.
Yeah. And so now it's like, okay, this is terribly efficient use of space in a column because now I have to resize my columns to be able to fit a few megabytes. So each row suddenly goes from, whatever records you have to a few megabytes per row, and we're going to blow up our space. That's terribly inefficient. How do we become more efficient? Well, let's instead write everything to a text file and then just have the relational database have the URL point to the file store or wherever that text file lives in on disk. And so now I've decided to move everything to text files, individual text files on disk. Does this need to be in a relational database or not? Well, these are all documents. And boom, the natural thing to do is to store these in a document database. Because they're documents, right? They're structured. And all we care about is their location on disk. So this could be anywhere from this could be a NoSQL database. We don't even need a database, technically. We just have it on disk and we don't give a shit, But you get my point there, right? You see how the narrative grew. It just starts with what does the user expect? Let's push it to its limit, and how can we become more efficient? It's the exact same thing over and over again. I want you to remember this. Always start with the user's expectations and how it impacts the system and whether we can be more efficient. What is the most obvious pain points that arises from that? And just keep going back over and over and over again. You will eventually grow your system just by doing that naturally. You don't have to think about the technicals. The joins, you're not wrong. Don't get me wrong. You're not wrong about that. It's just that you're starting to get into the technicals before you even solved the system itself. That's the wrong way to think about it. You want to have the system serve the user needs. Does that make sense?
Yep.
Okay, cool. And I want you to apply that heuristic a lot. That's going to help you a lot. I think, yeah.
Same.
Keep going. Okay, document, file type, file size, sure, why not? But that's all metadata. You don't really care about that. I would literally just say, hey, object store stores a bunch of documents. I don't give a shit about anything else.
Okay.
At this point, I'd make it an unstructured schema. I would literally just say document xyz.text. That's maybe timestamped or some shit. like timestamp plus user ID, and then that should be fine.
Okay.
Again, I'm just going with a very simple answer. If I turn out I'm wrong, I'll go back and revise it. But for now, it should. What we're talking about right now is just being able to get out of the way, solve the inefficiency just for now. That's good enough, and then we'll revisit it every single time we push like the user to we push the expectations of the user, or we grow the system.
Mm-hmm.
So it's very simple. It's usually a lot better to go to a very simple and more obvious improvement than it is to try and predict the future and go super hyper handle every single possible scenario we can in the future, unless it's plainly obvious. So
URL slash. So for that, let's do it.
so you're doing the hash now, okay? Wait, why did you? The question now is like, why did you decide to go here?
Handle whether the keys are used or unused, and what the user can get returned back to them for the uploaded document. So key generation service. Okay.
Okay, so shit. What's your reasoning for jumping to key generation service now?
This is another thing that I wrote down in what I did wrong.
Yeah.
Was I skipped this part in the. I skipped this part. I should have talked about this in my non-functional requirements and how we would get these keys in arguing whether you want to do the hash or the key generation service basically.
I see. Okay, so here's the thing. When I'm looking at Pastebin right now from Grokking, they actually don't say anything specifically about a key generation service. They just say, hey, I just want to be able to specify an alias or get a unique URL. In other words, the key is literally just a unique URL. So you gotta call it like unique URL generation service or whatever.
Okay.
So I would think that. What was the best way to phrase it? The key generation service is a way to implement the unique URL. So upload text file, get back unique. Yeah, and you even wrote a functional requirement, unique random URL. So in other words, to satisfy the functional requirements, you would just say you've kind of solved the upload a text file thing as long as you've solved the object storage, right? Now you just need to solve the how you're going to generate random URL. So that's the key generation service should be in this case should be, hey, I'm just trying to satisfy my functional requirements. It shouldn't be anything fancier than that. Does that make sense?
Yep, that makes sense.
Yeah. And I have a little chat at the end of this about like what I'm seeing the common problem here. Okay, let's see. Okay, relational database. I think we talked about this. Use and unused keys, retiring keys, TTL. Yeah, we talked about that already. Okay. I don't really need to see the rest of this actually. I think we've already talked about the rest of this. Okay. So overall, I think the theme of what I want you to take away from today is that everything starts with the user, and then where you go with it is about how where you start with the user, grow your system, find the inefficiencies, fix the inefficiencies, go get to the next thing. So what I mean by user, it could be like the functional, non-functional requirements. It could be what the user expects. It could be like, oh, well, what limitations of this particular item, right? And just I want you to keep like thinking back to that.
Okay.
And when you're doing these problems, because I get the feeling you're just what you're doing right now is, oh, I need to have this, I need to have this, I need to have this. But there needs to be some source of knowledge, some way you're guiding yourself. So in other words, if you continue down that chain of logic, you would continue to get the key generation service and then the cleanup service, and then you might get the metadata cache and block cache actually as well. So, and that being said, do you have any questions so far? Anything that might seem confusing, like, hey, this doesn't quite align with my practice or what I did for like homework or whatever? Does that make sense or not?
Yeah, it makes sense, man. Basically, driving. I think what I really need to nail down is driving this off the user, and then basically going back to the inefficiencies back and forth, right? Yeah.
It's this goes back to the thing I was saying, like good storytelling, right? It's like when you tell a good story, it's gonna have a it's gonna have like a character with a situation, and then has a but, and then there is some new stimulus, and then there will be a therefore, right? Have you ever seen South Park?
Yeah.
Yeah. So like they have the classic example is like a person goes to college, becomes a priest, and then becomes a father, right? Now, if I tell a story like that, each of these three things could be interchangeable. It doesn't really fucking matter, right? The person could become a father before he goes to college, and then priest could become a priest before he goes to college, etc., etc. It's not a terribly interesting story. But if you said instead he goes to college, discover and majors in religion, or majors in comparative religion, which then causes him to join the priesthood. But because he, had some traumatic experience in the priesthood, like I'm not playing religion, he decides to revoke his vow of celibacy and eventually becomes a father. You see how that makes a much more interesting story, right? And where I'm going with this is that what's going on here is exactly the same thing. The user expects that this service will do something, and because he expects that service to do something, he will act X. Therefore, it affects your system in this way. So, in other words, like as an example, the user expects to have, generate URL links for text files he uploads. Therefore, the user expects this to work no matter how big the text file is. And so, how would that affect your system? Oh, I have arbitrarily large content. I can't use a single relational database like you had. I need to be able to put that big-ass piece of text in a separate NoSQL database or document store. And you see how just that story and logic itself sells itself? Like, that was the thing we were kind of talking about in the beginning of the session. Sell me on it. Sell me on this idea that you need this. 9 times out of 10, if you just go with what the user expects and tell that story of what he's going to do or what multiple users will do if you start scaling it up and how it affects your system, that sells itself. So hopefully that's the big takeaway. I want you to keep thinking about. Think about how the user is going to use the system, how that compounds on the system being inefficient, and how you're going to fix those inefficiencies as simple as possible. So that's the takeaway from today's lesson. Any final thoughts? We have like 3 minutes remaining.
Okay, so for the envelope calculations, you just have to just come up with like simple numbers, right? Like the 25 instead of 26, right?
Yeah.
And as far as developing a heuristic for that, basically just look at examples for that. What do you recommend?
So when you're doing things like memory estimations, it should be plainly. Actually, I'll tell you straight up, I don't do memory estimations at all. It's like, this is technically the right way to do it, but I'm going to tell you just straight up, look at a system. I'm just going to go by user story and just do whatever the fuck they expect,
Okay.
And I'm going to take it to a ridiculous extreme. In this case, I said, hey, user might upload a gigabyte text file. They might upload their code base and shit. That's my heuristic. And that makes sense to me, but it might not make sense to a lot of other people because they might not be as in tune with the way users will use the system. So maybe they need to do hard numbers, right? But for me, like when I do a hard number, to me it's very obvious. Like, hey, wait a minute, calculating 26 times 2 or what? Going base 26 is very, very fucking hard. But if I go in base 25, it's super easy, and I'm within 10-15% of my final estimations. And plus, it's an estimation, so 10-15% is just a rounding error, really, at the end of the day.
Okay.
But you'll get better at this with practice, because the thing is, not only do you need to be able to do these system designs and estimations, you need to be fast at it too. Yeah. Notice like how each point I did, and even the points I did on Tuesday, they were all very fast.
Yeah.
So, and that's what that speed will come with time, but that also means that you just need to put in the time to do the what's called the full length, the go into every nook and cranny, and eventually you'll realize what is important and what is not. So for now, I don't care that you're slow. I care that you're complete and logical. So I would rather you see be complete and logical and take a little bit extra time with this than to say spend 30 minutes being sloppy. I'd rather you'd be complete. I'd rather you do that. Does it make sense?
Okay. Yep, that makes sense.
So homework. Keep it up. I want to see some, next time I see you, I want to see the practice diary. I want to see this chain of logic written down, this thing of, hey, they're doing this. What is the thing I need to add to my framework? And also, what I realized is with my past clients, I would tell them stuff and then say, yeah, move on. I want you to keep a central checklist I want to see next time. I want to see a checklist of all the questions that you ask yourself, all the tools that are in your toolbox that you use to basically do your system design.
Okay.
Okay, that's your homework. Does that make sense?
Okay.
Cool. We have 1 minute left. Any final questions?
Okay. Nope. We're good.
All right, sounds good. I'm gonna let you go.
Cool, man.
All right.
Thanks.
Yeah. Thanks.
All right.
Bye bye. All right. Any questions from the crowd, y'all? If not, I will just stop the stream because I haven't had dinner yet. So I'll put some Dota on. And if people want to chat or ask questions or whatever.
So what?
Oh, LTW's playing. Sweet. Look at this guy. That's a very, very good carry, actually. Okay. Oh, man, that push is going to be brutal from Lycan and P. I think it's a pretty even game, actually. The push potential is, like, super fucking good, so if Radiant, like, loses, like, a few fights in the next 10 minutes, I think they just get run over, but they have Aegis, so they have advantage. I'm curious, how farmed is Lycan? This Lycan might actually be a problem. You said 100 questions on lead code was enough. What's the difficulty breakdown in percentage? Also, do you recommend lead code premium? No. If you read the guide, I just say use lead code as a spot check. I think that if you're going to spend your money, buy grokking the coding interview and you do EPI. Between those two, that should be everything. Lead code is just I would say a backup plan. Like, hey, yeah, I did enough practice with EPI, elements of programming interview. After that, I don't care. That's, the lead code is just a bonus. It's just a spot check. So I said 100. I would say it's more accurate to say 100 hours in my guide. So just do, like I said, elements of programming interview. If you're doing it right, you'll know. And what's the difficulty breakdown percentage? I can't give you that. I don't even know. In fact, if you look at my profile, I don't even think I have more than 100 questions done on lead code, actually. What's the difficulty breakdown percentage? So you should be able to know, hey, yeah, if you have a practice diary, you'll know what you're screwing up on and what you're not. And just go after the ones that you're screwing up on. Like, hey, I really struggle with graph problems. I really struggle with array problems. Or I struggle with problems that don't have, patterns set to them. And so, in other words, if you're struggling with problems that don't really have clear patterns to it, do medium and hard problems. That, especially for the type of data structures that you struggle with, like graphs or whatever it might be. That's it. Do I recommend LeetCode Premium? Not really. I think like I said, there's better places to spend your money. And if you do like grokking, the grokking plus EPI. Actually, hold on. Let's do a price check. So grokking the coding interview. Let's see, hk.io. Again, I don't actually take sponsorship for this. I just do it because I want to. Because I think it's the best one. And this hasn't changed in 2 years, so I'm pretty consistent with my recommendations, I think. Let me log out of my account and see what the price is for grokking. Okay, let's say $16.66 per month, right? And then elements of programming interview. Let's see what the book costs. Okay, and then let's say use thrift books, $26, right? So $26 plus 16, that's what, 50, let's say $55, right? $55 one-time price for this, and then a month for this. Let's double this and say $32 plus $26. Let's say that's $70. You're in for $70 if you do it for 2 months. Let's 2 months, right? 2 months, $70, right? And then let's say what LeetCode Premium is. Okay, LeetCode Premium, $35 a month. Okay, in 2 months, you would have spent exactly the same amount of money. That's the thing. Actually, 1 month of LeetCode Premium is exactly worth it's worth more. It's like the value, the price you pay is more than what you would pay for just having elements of programming interview. Except you keep elements of programming interview forever. So I don't know. Bang for your buck, you get more out of this. So really, I'm giving you a cheaper alternative to this shit, or at least at price, you know. So I don't know. Just my grok questions? No. I'm recommending elements of programming interview. Grokking is just a starting point. I think what people are really misinterpreting from my guide is that grokking is to get your feet wet with patterns. But what's really important is that you do the whole process of, hey, here's what I'm doing right, here's what I'm doing wrong, here's the delta between what the book is doing, what I'm doing, and here's how I can avoid making these mistakes in the future. Grokking is just a starting point, but everyone just stops at step 1. I don't know why the fuck people stop at step 1. Like, let me look at my fucking guide here. Man, did I write something wrong? Welcome to the coding interview. You suck. Okay, let's see here. Update log. Let's look at the table of contents. Why you stuck? Okay, here's the. Let's look at the studying section. Study topics. Focus on one topic at a time. Yes. I don't recommend leak code until you finish this guide. Bro. In fucking bold. I literally write. You're not reading EPI, you're doing problems. That's the thing. You need to do the problems of EPI and go through the whole process of, hey, what's the book doing? How do they derive their answers, etc., etc. What questions do they ask themselves, etc., etc. That's the real practice. Like when you start reflecting back on your mistakes. Yeah, leak code is too inconsistent. I literally write this in the fucking guide. I don't know. Don't make mistakes. Yeah. Let's see. Otherwise, you pick these two up. Recommend these two follow. Understand how to study grokking. I write that here. Yeah, I mean, I write this in fucking highlight. Grokking and elements of programming interview. You must complete 60% of grokking before you go to EPI. I'm just looking at the bold shit, man. I write this shit down. I don't know, man. Okay, how to study EPI. Oh, why am I doing EPI? Oh, because I want to improve our efficiency. In the fucking guide. Here, timer and audio, record yourself. Can a 5-year-old understand? 5-year-old understand what I'm saying. Optimal solution versus your solution. Thought delta right here. Time efficiency. Code optimization. Alteration key points. Yeah. Yeah, be a solid example of doing all this. I'll link the videos here. Bro, I don't know. Everything's in the fucking guide. I don't know, man. I don't know what I'm missing. Even just me skimming through the guide, like I'm just going off like most of the bold and wording. I don't know. Honestly, I should just anytime someone asks a question about EPI versus grokking, I should just say read the fucking guide, bro. I should have a bot that does that actually. Hold on, I'm gonna make a note of that. Read the fucking guide. RTF. I mean, honestly, RTFM is it's really just an RTFM, isn't it? Just trying to suck less, yeah. Oh man, yeah, they got wiped here. Actually, this is probably where Dire starts peaking. Okay, oh yeah, the ways it looks like they're pushed out completely, so they can't actually push off the team wipe. The fuck? What the fuck is this Lena build? What the fuck is this Lena build? Okay, I guess E-Blade to protect themselves from the Lycan Wolves, sure. Spellcaster Lena? Is this a thing? The fuck? Okay, force staff for the trees, sure. Aether Lens? But why Aether Lens? Spellcaster Lena? Is that the build now? I'm gonna take like a Pro Dota 2 tracker. I refuse to believe that Lena is a caster right now. That doesn't seem right. Oh, bro, dude, fucking. Oh, safe to leave. Yeah, wow. He lucked out there. Okay, I'm looking at the past Lina builds right now. Mavis. Okay, crit. So this is support Lina. Peta. Okay, what a Falcon Blade. Oh, Aether Lens. Wow. So it is the build. Aether Lens into boss Move to Travel. Why? I guess Spellcaster Lina is the thing. Shit, maybe I'm wrong. I guess I'm wrong. Yeah, I mean, there's a few people who are doing right-click Lina, but I think most people are doing Spellcaster Lina. Holy shit.
Неужели я запустил стрим и не подстримлю? Не поиграю в нормальные игры.
I mean, it looks pretty consistent. People go for Spellcaster, Light Strike Array, Spell Amp, yeah. People are going Spellcasting Lina. What the hell? And then they, yeah. Why though? Was there a change to like the way Aetherland works? Damn. Okay, Aetherland's magical. Different range per ability. 300 mana. Cast range 225. Doesn't stack with cast bonus. It got nerfed. Reduced cost of it to 225. I don't understand. Why Aether Lens? I guess right click build's not as good anymore? Let's take a look. Did Lina get nerfed? Let me see. Lina.
Аркан на самом деле очень красивая. Не знаю. Я думаю, любому человеку понравится.
Oh shit, yeah, I see. Oh, it's because you're doubling down on Flame Cloak, that's why. I think that's probably why, actually. Because if you take long range spell and then you amp it by 30%, that's huge. Holy shit, yeah. I see. So you're stacking. The idea is to E-Blade stack Laguna damage and then blow them up with like 30% amp and then plus the 20% amp you get from Aether Lens plus 50%. You instantly do like 1,000 damage, I would guess. Yeah. That's the only reason I can see it. It's because the Ags got changed. I think that's the reason why. Alright. I guess that's it for the stream. Any final questions? I know I like talking about Dota, but like this is theoretical. I haven't played Dota in a while, so at least not like ranked. I've only just played like fucking casuals with friends whenever they invite me. But yeah, I guess I'll stop the stream for today. Thank you all for joining me. We'll be back on Tuesday, 8 p.m. Pacific Standard Time. So thank you all for watching. If y'all need coaching or something like that, I'm available in the Discord, or I'll answer questions, or y'all can sign up for coaching at eChantTech.com. Thank you all for joining. Have a good night.